Imagine an AI solving a complex math problem, not with a single guess, but by thinking through multiple paths, questioning its own logic, refining its approach, and finally arriving at the right answer not by luck, but by reasoning better than before. This isn't science fiction. This is the cutting edge of test-time compute, where the real magic happens after the model is trained, during the moment it answers your question. And today, we're diving into a breakthrough that's redefining how large language models think. Reward-Filtered Sequential Best-of-N, or RF-SeqBoN. A method so powerful, it's not just an upgrade. It's a paradigm shift in intelligent inference. Right now, the most common approach is Best-of-N, or BoN. You ask the model to generate n different answers, say 10, and then pick the one with the highest score. Simple, fast, effective for basic tasks. But here's the flaw: it treats every attempt as equal. It's like asking a team of experts to solve a problem, then picking the most popular answer, ignoring whether the reasoning was sound, whether the logic held up, or whether the best ideas were even noticed. And that's where the problem lies. New research from UCLA and Indiana University reveals a fundamental limitation. BoN is suboptimal. It's like trying to find the best route on a map by sampling random points. You might get lucky, but you're missing the structure of the terrain. So what's better? Enter RF-SeqBoN, Reward-Filtered Sequential Best-of-N. Here's how it works and why it's revolutionary. Instead of generating n answers and picking the best one in a single shot, RF-SeqBoN iteratively refines the model's thinking. Each time it generates a response, it's scored. Only the high-scoring ones are retained and injected back into the prompt, like adding a memory of what worked. It's not just selection. It's curation. It's learning from its own best attempts. Think of it as a critique session, not with a human, but with the model's own past performance. The model learns what good reasoning looks like and starts to emulate it. This isn't just a tweak. It's a feedback loop of improvement. The model doesn't just answer, it refines its own reasoning in real time. And the best part? It's provably better. The researchers didn't just run experiments. They proved it mathematically. Under realistic assumptions about how LLMs are trained and how rewards are estimated, RF-SeqBoN converges to the optimal answer with far fewer tries than BoN. In fact, on hard reasoning tasks, like advanced math, logic puzzles, or multi-step scientific reasoning, the gains aren't marginal. They're transformative. Look at this. On MATH500, RF-SeqBoN with just 32 tries surpasses BoN with 64 tries. And on harder problems like the AIME, the gap widens. The more complex the task, the more RF-SeqBoN pulls ahead. This isn't just faster. It's more efficient. Less compute. Better results. Lower cost. Better scalability. Let's see it in action. BoN gives a wrong answer, 28. A naive sequential method, feeding back all answers, gets stuck in loops, repeating the same flawed logic. But RF-SeqBoN, it keeps only the high-scoring attempts. It learns from its own best reasoning. It refines its approach. And finally, after a few iterations, it arrives at the correct answer, 52. This isn't theory. It's working in practice, across models of all sizes. From small 0.6B models to powerful 4B ones. It's robust. It's general. It's not a lab trick, it's a new standard. So what's the takeaway? Best-of-N was a breakthrough. But it was only the beginning. With RF-SeqBoN, we're moving beyond selecting the best answer. We're enabling the model to become better at thinking. We're teaching AI to reflect, to curate, to learn from its own experience, all during inference without retraining. This isn't just about accuracy. It's about intelligence in action, where computation isn't just raw power but structured thought. So next time you use an AI, whether it's solving a math problem, writing code, or explaining a concept, remember, the real magic might not be in the model's training. It's in how it thinks. And with RF-SeqBoN, it's thinking smarter than ever. Thanks for watching and stay curious.